अस्सलाम वालेकुम डियर स्टूडेंट्स, वेलकम टू माय यूट्यूब चैनल मैथ एक्सपर्ट। स्टूडेंट्स, अगर आप हमारे इस चैनल पे नए हैं तो काइंडली मेरे चैनल को आप सब्सक्राइब कर लें, क्लिक द बेल आइकन, एंड इफ यू हैव एनी क्वेश्चन रिलेटेड टू दिस टॉपिक यू कैन सेंड अस बाय email or in the comment section. Today we will have a problem of differential equation modeling or application of the differential equation. Here the problem is the static deflection y of x of a uniform beam. We have a uniform beam of length L carrying load W of x per unit length. Okay, this is the model equation of the of the uniform beam. Here we are given this equation EI d4 of y divided by dx की power 4. This is the fourth order ordinary differential equation is equal to w of x, where w of x is equal to w naught into 1 minus 2 by l x, where 0 is less than x is less than l by 2, and it is equal to 0 when x is greater than or equal to l by 2. It's mean the load w is in the half of the beam when the length of the beam is from 0 to L. So in the half the load is W naught into 1 minus 2 by Lx, and above the half interval it is equal to 0, where you know that E is the Young modulus of elasticity, I is the moment of inertia, and here it is a boundary value problem. So y of 0 is equal to 0, y prime of 0 is equal to 0, and y of L is equal to 0, y prime of L is equal to 0. So now we will see the geometry of this equation. For geometry, I will share the screen with you. You can see here, for example, here you can see this is the load W. Okay, this is the load on the beam. This is W of x. So L by 2, here is 0 and here is L. So from 0 to L by 2, the W naught, W of x is equal to W naught into W naught into x1 minus 1 minus L by 2x, and from above this from 0 to L by 2 to L, it is equal to 0. So this is only in the interval 0 is less than x, less than or equal to x, x is less than or equal to 1 by 2. So now here this is the wall, the fixed end of the beam, here is the another fixed end of the beam. So now we can solve this by using the Laplace transform. Now we return to our whiteboard. Here is our whiteboard. So we will solve this by using Laplace transform. So we will solve this. So we take the Laplace transform of the equation. So original equation is basically, we will first write the original equation. Original equation is EI. E is the Young modulus of elasticity. EI d4 of y over dx की power 4 is equal to w of x. And if I write w of x, so w of x is a piecewise continuous function which is equal to w naught into 1 minus 2 by L x, which is 0 is less than or equal to x is less than or equal to L by 2, and the other piece is 0, x is greater than or equal to L by 2. So it's mean if I write here the condition, like if we have this beam, the one end of the beam is fixed, okay, this end is fixed and the other end is also fixed. So here is this is 0 to L, and here we have L by 2. So the piecewise continuous function W naught, this is the piece of the first piece, W naught into 1 minus 2 by Lx, and the other piece, this one is equal to 0. when x is greater than or equal to L by 2. Okay, students. Now we will convert this into we convert this into compact form. Compact form by using unit step function. Okay, you know that in previous lecture I will give you some techniques how we will convert the piecewise continuous function to a compact form by using unit step function. So we will write here w of x is equal to the first piece w naught into 1 minus 2 by Lx into u of x minus 0 minus u of x minus L by 2. Okay, students. Then plus the other piece is 0, and when we multiplied something with the 0, it is equal to 0. So the first piece we get w of x compact form is w naught into 1 minus 2 by Lx into u of x minus u of x minus L by 2. This is the compact form of the unit step function. So if we simplify this w of x, so we get a function of this form 2w naught over L into L by 2 minus x plus x minus L by 2 and u of x minus L by 2. Okay, students, this is the compact form of the unit step function. So now we will use Laplace transform. So the Laplace transform is applied on the equation EI d4 of y over dx raised to power 4 is equal to 2w naught by L into L by 2 minus x into plus x minus L by 2 u of x minus L by 2. So now if we apply the Laplace transform, so you know that Laplace transform is applied on the both side of the equation. So we will apply the Laplace transform of this side EI d4 of y over dx raised to power 4 is equal to 2w naught by L is a constant. So we will remove on this another side, and the Laplace transform of the each step. So Laplace transform of L by 2 minus Laplace transform of L by 2 minus x plus x minus L by 2 u of x minus L by 2. So this we will apply the Laplace transform on this step. Okay, students, this is the we apply. Now we apply the Laplace transform EI. So Laplace transform of the fourth derivative, if you don't know, you will see our video in the same playlist how we will apply the Laplace transform of the derivative. So capital Y raised to power 4 capital Y of s minus s ka cube y of 0 minus s ka square y prime of 0 minus s ka s y double prime of 0. Okay, students, s y double prime of 0 minus y triple prime of 0 bracket close is equal to 2w naught by L. And now Laplace transform of L by 2. So L by 2 is a constant, and Laplace transform of 1 is, you know, that 1 by s. Okay, student, minus Laplace transform of x is 1 over s ka square plus, and this is the, here we use the formula. So you know that if we want to apply the Laplace transform on this type of function x minus L by 2 and u of x minus L by 2, so we will use a formula you know that we will write this in this form: 1 by s ka square e raised to power uh, minus L by 2. Okay, students, I will write here the formula for you, which I use here. Uh, uh, I will write here formula. If we want to apply the Laplace transform on this type of function, Laplace of f of t minus a u of t minus a. So this will be equal to e raised to power minus at capital F of s. So I will use this formula here. Laplace transform of x is 1 by s and 1 by s ka square, and Laplace transform of e raised to power minus at. Okay, students. So now this is our formula we will use here for your clarification. And if you have any difficulty in this, you will see my previous video. Okay, students, now we will move to our next step. So you know that we are given some conditions. I will write again here condition for your easiness. So we are given that y of 0 is equal to 0, y prime of 0 is equal to 0, y of L is equal to 0, and y prime of L is equal to 0. First, we need these two conditions: y of 0 is equal to 0 and y of L is equal to 0. We use these condition here because we will use these condition in this here. Y of 0 is equal to 0, y prime of 0 is equal to 0, and when someone derivative is equal to 0, his double derivative is also 0 and his triple derivative is also 0. So we get ei s raised to power 4 capital Y of s minus 0, and the second y prime of 0 is equal to, this is also equal to 0. Sorry, this is also equal to 0. Y prime is equal to 0, and let we call it minus c1 plus c2 is equal to the other side of this our equation, which is equal to 2w naught by L by 2, 1 by s. We have the other side of the equation, 2w naught by L into, we have L by 2, sorry, not L by s, we have L by 2 into s minus 1 by s ka square plus 1 by s ka square e raised to power minus L by 2. Okay, students. Now see that if we divide this with another side, we get y of s is equal to, capital Y of s is equal to c1 divided by this ei will divide with this, not c1 and c2, s raised to power 4 plus here we have minus, not plus. If you see previous equation, we have here minus. Okay, students, we have c2 divided by s raised to power 4, and one thing here, we have also with this equation with s, so this will be equal to s raised to power 3, s raised to power 3 plus s raised to power 4 plus 2w naught divided by ei L, and then we have L by 2 our s raised to power 5, because this s and this s raised to power 4 will combine with make s raised to power 5, 1 divided by s raised to power 6 plus 1 divided by s raised to power 6 e raised to power minus L by 2. Okay, students. Now we will apply, because we get y of s, so we need y of x. not y of s. So we apply using inverse Laplace transform. So we'll apply the inverse Laplace transform. Inverse Laplace of y of s is equal to inverse Laplace of c1 over s का cube plus inverse Laplace of c2 over s raised to power 4 plus 2w naught over EIL inverse Laplace of L by 2 over s raised to power 5 minus 1 by s raised to power 6 plus 1 divided by s raised to power 6 e raised to power minus L by 2. Okay, students, if I will, for your easiness, I will remove Laplace transform here, inverse, and this inverse, and I will put the inverse in this form for your easiness. I will apply inverse Laplace here, inverse Laplace here, inverse Laplace here, and inverse Laplace here. So you know that this thing will be equal to y of x is equal to 1 divided by s ka cube. You know that the formula for this type of, if we have, I am applying the inverse Laplace on 1 divided by s raised to power 3. So you know that this is equal to, we apply here 1 by 2 factorial, 1 by 2 factorial, inverse Laplace of 1 divided by s raised to power 2 plus 1, and here we have 2 factorial. So this will be equal to x ka square. Okay, students. So we will use this strategy to complete the inverse Laplace transform. This is only for your understanding. So here, if I multiplied this 1 by 2 factorial, inverse Laplace of, here we will remove this c1 on the back side, c1. Here we will write 2 factorial, and then I will write here s raised to power 2 plus 1, and this bracket close. Okay, students, plus. Similarly, if I will write here c3, here we have c1. Don't confuse in these are basically constants, divided by 3 factorial, because we have here 3 plus 1, so we write 3 factorial, and then I will write here 3 factorial over s raised to power 3 plus 1, and the bracket close, plus. Similarly, I will write here 2 w naught over EIL, and the inverse Laplace of each step. So we will apply the inverse Laplace on L by 2, inverse Laplace on 1 over s raised to power 5 minus inverse Laplace on 1 over s raised to power 6, and then plus inverse Laplace on the 1 raised to power s raised to power 5, 1 over s raised to power e raised to power minus L by 2. Okay, students, we will apply the inverse Laplace individually. So look at this, we get y of x is equal to c1 over 2 factorial, and we have here x ka square plus c2 over 3 factorial, and then this is equal to x ka cube, inverse Laplace of x ka cube, plus w naught over 60 EIL. We take something common, and this will make 60 over 5 L by 2, and here we make 4 plus 1. So we will multiply this 1 by 4 factorial, and here we put 4 factorial. So we get this. So this will be equal to x raised to power 4 minus x raised to power 5 plus, and here we will inverse formula, same inverse formula I will tell you in previous step. This inverse of this f of t minus a u of t minus a. So I will write here f of t minus a, which is equal to x minus L by 2 square and u of x minus L by 2. Okay, students. And finally, we get y of x is equal to c1 by 2 x का square plus c3 over 3 2s are 6 x का cube plus w naught over 60 EIL into 5L by 2 x raised to power 4 minus x raised to power 5 plus x minus L by 2 square u of x minus L by 2. Okay, students. Now you know that we are given another condition. The another condition was y of L is equal to 0 and y prime of L is equal to 0. So we know we want to use this condition. So first we if use this condition, y of L is equal to 0. We get the equation of this form. If we use this condition, y of L is equal to 0 and y prime of L is equal to 0, we get C1 L square by 2 plus C3 by 6 L raised to power 3 plus 49 W naught L raised to power 4 over 1920 EL. Just make calculation. L raised to power 4, L raised to power 5. Here we have, we put here L and L. So combine all these and u of L minus L by 2 and use the unit step function, we get this equation. Now using y prime of L is equal to 0. So we get another equation, call this equation A. Call this equation A. We get C1 of L plus C2 L square by 2 plus 85 W naught L raised to power 3 over 960 EI. Call this equation B. We solve this equation for C1 and C2. Solve A and B for C1 and C2. We get C1 is equal to 23 W naught L का square over 960 EI, and we get C2 is equal to minus 9 W naught L over 40 EI. So we will use C1 and C2 value in the final solution. We get y of x is equal to C1 23 W naught L का square over 960 EI x का square. Then C2 value, C2 is 3 W naught L over 40, sorry, not 40, we have 80 EI x का cube plus W naught over 60 EIL into 5L by 2 x raised to power 4 minus x raised to power 5 plus x minus L by 2 raised to power 5 u of x minus L by 2. So student, this is our final solution of the deflection of the beam. It is easy to solve this by using Laplace transform. You can see here we use Laplace transform to solve this and find the solution. If you have any problem, you will send us via email. Email is given in the description of the video, also in the comment section. Please do subscribe my YouTube channel and click the bell icon. Thank you.